we'll start off with, I'll try to be quick, and we'll start off with the interview of Mahi. Is Mahi around? Or should I ping her?
Yes, I'm around.
Okay, you don't have to show off. All right, should we turn on our cameras maybe? Okay. Nice. So I'll be using LitCode interview mode for this one, and let me share you the link.
Should I start sharing my screen?
Yes, you should, I guess. And gotta open the link first. Okay, we're there. Let me copy the question for you. So in case this is going to be confusing, if you're not used to this is just going to be a whiteboard that you have where we can give you the question and you can do whatever you have to. And we can just discuss anything we need here. And once we're ready for implementation, I'll move you to the code section, or the basically regular LitCode section of the question. Is that fine?
Okay.
Okay, so I guess you can start by introducing yourself.
Okay, hi everyone. My name is Mahlet. I'm a fifth-year software engineering student here in our AIT. I'm generally interested in machine learning and emerging technologies. I have been with A2SV for 2 years now. Yeah, that's it.
Nice. Okay, if you don't have anything else to add, I can give you the question. Are you good?
Yes.
You're using Python, right, still?
Yes.
So, read it. If you have any questions, let me know. And if you need me to explain it or anything.
Okay. That if you only sort this in a single order, then the whole array will be sorted in a single order. The shortest such value and output its length. Okay. So I'm given with an array of numbers, and there are some there might be some numbers in the middle that are out of order, and if I only sort that part, and if I can sort if the other part of the array stays the same, and if I can sort that part, that part, and the whole array becomes becomes sorted, I should return the length of that sub array, which is shortest from all, right?
Yes. Okay. And just as an additional clarifier, what would be the answer if the question asks for the longest such array?
Yeah, the whole array.
Exactly. Nice.
Yes.
Any other questions you have, maybe?
Should we should be the sorting should be in strictly ascending order? Is it strictly ascending?
in ascending order. Yes, the description says so.
Okay. And we might be given with a sorted array also. Then in that case, we should return an empty array or sub-array.
What are we returning?
Like if everything is sorted in ascending order.
What do you return?
Like an empty sub-array, because we don't like we don't need to.
We're not returning any subarrays.
Okay, it's linked. We are returning. It's linked. Yeah. Okay. Then we are returning 0 for this case.
Yes, I agree.
Okay. So okay, like given this, if like let me try to see with an example. So like up until this moment, 2 and 3 were sorted, and after this, like 4 is out of order. So like this array is not sorted anymore. So I need to sort this part, and so like one more question: are like the sub arrays that we like we took out of the names array, are they like being sorted in the that sub array section? Or
I'm not sure what you mean. So are you asking if the subarrays that we're considering as a result are sorted within themselves?
Yes, like for example, how come we have like 5 for this example? Can you walk me through this?
I forgot to show you the explanation earlier. So if it's sorted, if it's this like the part that's not in a sorted order is these 5 elements. So if these 5 elements are sorted, then like 2 and 15 are basically gonna fit in and become a whole sorted element, a whole sorted array.
Okay. All right. So like for this one, like let's assume that we have sorted array up until here. Then we start to add 6 for this one, and it will be sorted. And we'll try to add 4 after 6, like so. It's not sorted, so I need to like the correct position for 4 should be something like after 2. So we should sort these 2 arrays for it to be in ascending order. Then else so this should swap. So we have like this sub array that needs to be sorted up until now. So if we assume that like these 2 elements got into the same like if they become sorted, we'll try to see if we can add like this element into the sorted array. We can. So we move on. For this one, we also see that 10 can be added here without any conflict. We move on. And for 9, we need to sort like sort the array for it to be in order. So it should be added here, and yeah, like 9 is not, we cannot add 9 to the sorted array anymore. So 9 should be sorted. So if we add like 9, swap this and so like we have had like this like unsorted subarray here, and we move on after that one, and we have found another like unsorted subarray here. So these two should merge. Otherwise, like in one operation, we can't. Even though like numbers in between are in order, they should like we only need to find one subarray. So these two should like merge and make the subarray bigger. Then we move on to see if you can add the given element to the sorted array. If you don't have a sorted, like if you don't have, if we can add the given number to the sorted array, we don't do anything to the previous like sub array that we accumulated. So let me think if you can do.
So to rephrase what you're saying, if I'm hearing this correctly, you plan to go through the array. Let's use the example, I guess. You plan to go through the array whenever you find something that's not in its place, I guess. Or something that's smaller than, I guess, whatever it came first, you have to move it backwards, right? Is that what you're trying to do?
Yes, like this should like change its place and something in the like in front of the sorted array. So this is out of order for the previously sorted array. So like I keep doing that, and if I have a previously like a previously out of order sub array that I have accumulated, and if I found a new out of place number in my iteration, I need to like maximize the window that I was previously accumulating for finding elements.
Okay. So, for example, if this one, if its value was 1, for instance, what would happen?
So for this one, so for this array to be in a sorted order, this whole array should be in a sort like it should these all numbers should be in a sorted order, right? So our shortest subarray will be like 5, or is it 5 or 6? 6.
6.
Yes. So like with the previous approach, if I have seen that like 1 and 6 like they were in order and they are sorted, and if I came across 1, 1 should be like swapped with like something that was that we like with some numbers like in front of it. So like it should go until like 2 for it to to be in the right order. So like I shouldn't only like look on the previous element, but I should look on the right place for the given out of order element. So like while doing that, these two will be affected, and yeah, like my window will be 3, and when 8 comes, it was in the right order. So we move on, and with 10, this is also like in the right order, and with 9, we need to move 9 into its right place. So we can just swap this with 9, and like after that 15 is like the maximum one, and we need to find like we don't do anything for 15, and we have like seen that we have changed this whole array. So our sub array would be the length of the sub array should be the whole thing. So
yeah. So basically, I think this is starting to look like more of an insertion sort, right?
yes, yes.
So for each element, you insert it to wherever it belongs, and what do you do? Like, I guess the first time you swapped it, and then the last time you swapped it would be the window.
A window. So like for a given number, it might go up like to the end or to the start of the element. So if I am like swapping everything in the up until like that some number, I need to see like to update my start position for my sub array like backward. And if I have gained any element that's out of order from my new iteration, I need to update my end element, like end point for my window. Is that right?
Okay, makes sense. Makes sense. And what would be the time and space complexity for this?
So like in worst case, I would have a reversed array, and for everything I should do, like I should look for the right place in the right place of a given element, and I would iterate over all the elements that I've seen in the previous one. So in terms of time, it will be O n square.
Yes.
Like, yeah, n being the length of the array.
Okay. And space?
And space wise, so I will be using like I will be swapping in place. And yeah, I wouldn't be like having any extra space. If you don't consider the given array to be an extra space, it will be O1.
Okay. And obviously, I guess, can we do this better? Actually, you can try implementing this as well, but if you feel like you can do better, that's a challenge, I guess.
Okay. Okay, so like one thing that I was thinking is like without swapping everything, like trying to accumulate the maximum that I've seen so far for the coming element. So if it is greater than whatever that was seen in, like from the previous iteration, I don't need to swap its place. But like for finding the right position, like from the for the coming number, like for the given iteration, I need to like to find the minimum like the minimum numbers that I have seen, or so like for a given number, like for example for 1, like we can always see that 6 is greater than 1, so it will be out of order. But for finding its like right position, we need to find the maximum number that like that is greater than like the number that's greater than the given number. So we can place it in the like in the like right before that one.
Oh, so you're planning to move 1 to the maximum number before it? Is that what you're saying?
Like the maximum before the maximum number. Yeah, sure. 1 should be
right?
Placed before 2. Yes. Yes.
So what's the cost of just moving after finding its place?
Like if I'm trying to shift everything, do you mean that?
Yeah, is there a way you can do it otherwise? Maybe.
Yeah. Like I'm not actually thinking of shipping all the arrays.
What are you thinking?
So like I'm thinking of having like a minimum and a maximum elements with their index, and like if for a given number, for example, for 1, the previously seen maximum number is 6, and yeah, it's placed at like at 1. Okay. It's 0.
Okay.
And it's placed at 1. Okay. And like it means like if it is less than the maximum, it's not in the right place. So for it to like, if I have seen like 1 in the element, like, for it to be placed in far, like from in the right place, if it is less than the minimum number that I have seen, it has to go 1 before that, right? So like if I like hold the index for the minimum number that I've seen and put it like before that, it means like I can put it before that, but if it is in between, like for example, if it is 3, it just needs to be placed before 6, right? Not 2. So I need to see the minimum number, or the maximum, like the greater number from the given number up until that one. So okay, I still need to iterate, like if it is not less than the minimum, I still need to iterate that way. So
yeah, I think that makes sense. Yeah.
so like yes, if I put it like on a stack, the minimum index is on a stack, and if I keep like looking the maximum number that I have, like the maximum number less than the incoming one, and like keep track of that, but still it might be off in, like, that operation might go off in.
Yeah, because you can't really tell where it's going to end up, right?
Yes.
Could be in the middle, could be different. But what if you could? So, for instance, for 3, what if you knew where it will end up? Would that be helpful?
Yes, like if it is out of my current window, like back from my current window, my current window will be like maximized. But
so, like, is there a way you can tell where the proper place for 3 is, or something? Is there a way you can determine that? For instance, what's the proper order of each of the numbers?
I didn't catch that one.
So this is the list of the numbers, right?
Yes.
What's going to be the proper order of them, or what's the proper position for them, for each of them?
Sorted ones, right? So this should have been 3.
9, 10, 15.
Okay, 15. Yes.
Right.
Yes.
Maybe
So,
knowing these orders and considering it,
yes.
how would that help?
Yes, because like if I have like a sorted order and okay. So it is like positioned in like some key place from the actual position. So if this helps, okay, let me see.
So which window is the part that has issues now?
So like the ones that are like out of order. So the first element that I've seen an element to be out of order, and the last element, like the last place that I've seen elements in out of order. Like this is the maximum window, the maximum window that like I need to have like to sort everything. So like in the middle,
right? How do you determine?
So yeah, I can have like if I can use an extra space, or like if I source a given array, and like for each place in the given like the given array, and it's sorted part, if it is like different, and I'll start my like if I haven't seen any distortion before, this will be my start index of my window, and my start in my end, and try to look for other places in which I've seen a distortion. And the last distortion that I've seen will be the end of my window, and like the difference between the two plus one will be the window, like then the elements that I should swap or sort in the array.
Yeah, that makes sense to me, I think.
Okay.
So if I, to rephrase this, so what's your steps maybe? For each element, you're going to compare the sorted and non-sorted, right?
Yes, like from the sorted and non-sorted part, and like if I see a distortion, I would start like I will point that place as a start and end, and like move on until I find the last distortion. Then like the last distortion will mark the end of the window, and the first distortion will be the start of the window, and the difference.
Makes sense. Yeah. So basically, you're tracking the first disconnect from the sorted one, and the last disconnect from the sorted one. That should work, I think. And what would be the time and space complexity of that? And is it better than what we have before?
So the time will be of like n log n for sorting. So the sorting will take n log n time, and we'll iterate once more for comparing, but n log n, and we'll be using extra space because otherwise we will be losing the order, the elements order in the given one.
Makes sense, yeah. Okay, yeah. That makes sense to me. Is there a way to make it better maybe? Like, do you think you can make it better still? I mean, yeah, do you have any ideas that could make it better? Or if you want, you can still implement this, or you can try to make it better if you can.
Okay.
I don't know. We've gone for 27 minutes since, like in the last interview, we went for 40 minutes. We can each have some more time.
Okay.
You have 30 minutes basically.
All right. So we need to wait at this. So like what I'm thinking right now is like if I can place a given number like between two minimum and maximums here, and like so there is
What's
like
that? I don't understand.
so like there is a
Mhm.
window of a sorted part in my array, and there is a window of like elements that are out of order. Then like a given one, a given number, if it is like out of order of the like if it is less than the minimum number, like the minimum number, okay, it's greater than the maximum number in my window, and less than like the minimum number in my window, it means it's gonna like distort the window. So if I can update that one with this one, like for example,
Yeah, run it through an example. That's right.
yes, and let's assume that this is res one, and like I have so I have a window sorted array, and I'll contain this. Then I'll try to update this one and try to update the sorted array, and like I don't have the any element in my out of order array. Then like if it is less than the maximum one of the sorted array and less than the minimum one of the sorted array, this should be like this should be the so this sorted array should be like become bigger, and like one should be placed before the lowest element in my sorted array. And
Yeah, but in the case of 3, how would that go?
so in the case of 3, yeah, it will be in between. Okay, still I have the okay, I need this. Yeah.
Okay, so you're trying to go for, if I'm reading this correctly, you're trying to see if the next element you fit will disrupt your sorted array or not, right?
Yes.
Okay, so your method of checking is if it belongs within the bounds of minimum and maximum, right? That sorted array. If you look at what you did here, this could count as your sorted array.
Yes.
6 has already disrupted your sorted array, but you haven't detected it. How would you detect that 6 is a disruption? What does 6 is a disruption mean?
So like it means that there is like a lesser element after 6 that should have like gotten the place 6. So
so because there's a smaller element to the right, 6 is out of place.
Right? Yes. Yes.
Okay.
And okay, how can we see that? Okay.
So how did you detect that there's? Okay,
yes.
continue. Sorry.
Okay, so like if I have if I keep track of like the minimum element form right here, and so when a given element to be in the right place, everything before it like should be less than the given number, and everything after it should be greater than the given element for it to be in its place, right? So if I keep track of like the maximum number from the right, so like this will be 2, 6, 6. So 6 is still the maximum, and 8, and 10, and 9. Okay, and 10, and 15. This is like the minimum number, like the maximum number from the right, and from the left, if I keep having the minimum number that I've seen from the left, so 2 was the minimum number that I would see, and for this 3, I guess 3, 6, not 6, I think 3, out 23, and 8, 9, 10, and 15. Can you check this?
10, I think, not right.
Yes, 9 should be here,
Yeah.
and yes. So like if for this one, yeah, 15, 9, 9, 9. So like iterating over the given array, if it is less than okay, we can use sampling. So, and if you have like negative infinity here, and okay, like something infinity here. So for the given array, so, if it is less than anything that's like before it, and if it is greater than everything before it, and if it is less than anything, the maximum numbers that I've seen from the right position, it means it's in position. And for 6, I can see that like the minimum that I've seen from up until that was 2, and the maximum, like the minimum number from the right was 3, like going forward. So we can see that 6 is out of place. So yeah, there is less element than 6 in the right position, and I like this is like the start of a distortion. And for 3, yeah, you can see that like we have seen 6 before it, and from the right, yeah, it's in the right position from the right, but from the left 6 yeah. So this is also,
I think I understand.
yes,
I understand what you mean. So basically, you just changed your way of detecting distortion. Instead of comparing it with the sorted array, you're comparing it with whatever is the biggest from the left and whatever is smallest from the right.
yes,
Right? Yeah. Since you don't have too much time, I think that makes sense. Maybe you can start implementing either one, whichever one you feel comfortable with. Like if you feel like you can implement the most. By the way, what's the time and space complexity for this one?
this would be of n. Time would be of n.
Okay, time is of n. That's definitely better, right?
Yes.
So if you feel like you can implement this in time, do it. Like you have up to 5 minutes, I guess. Otherwise, implement whichever one you feel like. I'll switch you to the question, if you want, that is.
Okay. Okay.
Can you see the question now?
Yes, I can see something. Okay, so Okay, let me start with the sorted one, and I can switch back to this if it is if I
Whatever
can
you feel.
still have. So I can. Okay. It means I haven't found any distortion. So then here, else I should return. So okay, let me run it on a given example. So like for the given one, so like I'll iterate over the
Maybe what kind of examples would you try on this while you're trying?
what?
What kind of examples would you try?
With this one. So like
write them down and test them.
Okay. So this one, and like if I don't have any, and yeah, sorted one or like reverse it. I think this would be enough. And one, maybe like if I have duplicates. So like first, so I would get to this position first, and my start would
No,
be.
I think you can just try running it first because we don't have time. Sorry.
Oh, okay.
If you feel, when you feel comfortable, I can submit it for you from my end.
Okay.
And see if it works.
So for the given one, yeah, it works. And okay, what is two, four, okay. So like let me try one more. Yeah, this one is 270. So Yeah.
Anything you want to do?
I think it's fine. Thinking of one, some edge cases. So there's a recursive one. That's fine.
Yeah.
Yes. Okay. I think it's fine.
Okay. Should I submit?
Yeah.
Yeah, it's passed. Okay. Yeah, thank you, Mahi. And I think we should move on to Nati, and I'll text them.
Okay.
Let me know when Nati joins, because I can't see. Someone can let me know, maybe. Is he already here? Hello? Any Natis here? Any Nati B's here? I don't think it's. I guess until he joins, you can ask. Oh, Nati B is here. Nice. Hello, Nati B.
Someone? Can you hear me?
Yes, I can hear you.
I'm good, man.
Awesome. Yeah, there's probably people that don't know you, so maybe you can start with introducing yourself. And hi, how are you doing? How are you doing?
And
turn on your camera.
Fine. Okay. Can you see me?
Yeah.
Okay.
Okay.
Yeah, so I'm Natnael Bekele, and I'm fourth year electrical engineering student. And I am from the second group of A2SV. And it's been like a year now since I joined the team now.
That's nice. Give me a minute to set things up. So I've sent you a link. Do you see it?
Yeah.
Maybe you can start sharing your screen and we can start discussing. So as soon as you join, the timer starts. So when you join, it starts basically. When you open the link.
Yeah. Should I set up the? I mean, it's asking me for my name and something like that. So
yes.
Okay.
There you are. Nice. Okay. Nice to do this with you, like we just did with Mahi, I guess. So I don't know if you're familiar. I guess you're not familiar with the interview tool because you hadn't set up your name yet. Okay, so how it works is you can share your screen. Yeah, you already shared your screen. So how it works is right now this is the what do you call it? The whiteboard, I guess. From my end, it's calls it the whiteboard. And once we've done all our discussions, and it doesn't matter what you do here, this is more like a free zone. And once we are good with our discussions, we can move on to the actual code area, which is basically the lead code you know, right? So this is more like a playground, and you can do lead code. We can try submitting and stuff. So, all right.
Can I run things here?
You can, but yeah, you can't. I don't know if you need to. Whenever you need to do code, I can switch it to the question. This is just for discussions.
Okay.
So you may not even need it to be in C++. It's just whatever you want.
Okay. In case, let me use the STD. Okay.
Does people not already import those? Okay. So I should give you the question, right? You're good?
Yeah, I'm good.
All right, I'll paste the question here, and yeah, read it, understand it. If you need any explanation or any questions, feel free to ask me.
Okay. Okay, so it says we are given an array which is called nums, and in this array, we got some sub arrays. If we sort them in ascending order, then we don't have to sort the others. The whole array will become just sorted in ascending order. So it says return the shortest of such sub array, which means there are different sub arrays with different lengths. If you sort them, then you don't have to sort the rest of the elements. The array will be just like sorted in ascending order. So I'm supposed to return the shortest of such sub array.
Yes, that makes sense. And just to clarify this, what would be the answer if the question was the longest such sub array?
Yeah, it will be just the whole array itself. You can just sort the whole array, then it will be ascended in as it will be sorted in ascending order.
Makes sense. Yeah. All right. So here's an example. Maybe you can try to explain this, or I can explain it to you.
Okay, so here okay, it says, I mean, our aim is just to sort the whole array in ascending order, but here we can see that 2, 6, it says 4. Here it's not sorted, it's feasible. So if we sort like, okay. See, if we sort this part, then the whole array will be sorted in ascending order. So we are supposed to return, I think, the length of that subarray, the shortest subarray.
Yes.
Okay.
That makes sense. Because I don't think you can get shorter than that, right?
Yeah, right. Since 15 is the maximum element. Yeah, right. Okay, so should I run over another examples, or do we have another inputs?
Yeah. No, you come up with examples if you want, and whatever helps you understand the question. And if you have any questions, feel free to ask me.
Okay. How long will be the length of the nums? Maximum length, and maybe the constants, yeah.
All right, let's go with 1,000.
Okay, 1,000 elements. And the minimum one?
Minimum is 1.
And it doesn't matter. We have do we have the duplicate elements in here? Can we have
Yes.
6? Okay. Yeah, then I mean, if the constant that we are going for is 1,000, just speaking from experience for our participants with less experience of problem solving, I'm not saying here that I am experienced. It's just just to go, if you are taking the community path, if usually the length of the nums or of the array you are dealing with, it gives you some signal of how you are going to approach the question. So if it says 1,000 elements, I mean, I can do a lot of operations, 1,000 times 1,000, maybe even 1,000 times 1,000 times 1,000 operations. So in case
maybe I don't know if that works in C++, but usually that
in the
wouldn't
power
go
of 9,
right. In the power of 9 is too much, I think.
Yeah. Okay. Let's see. Yeah. It's just the idea is the constant can give you some signals of how to solve it. So in here, what I'm thinking is, for example, in this example, why I stopped at 9 is because 15 is the maximum element in the array, and I don't have to include this one since it is at the last element. Okay, let's see if that's okay. I think the brute force approach is just, I mean, the brute, you should say, if there is another expression, I don't know, but the brute force approach is to sort all the sub-arrays here, starting from the minimum ones, and check if the array is sorted. Like we can sort. There is a partial sort function in C++. We can sort some part of the array and check if whether the whole array is sorted or not. But that will take the time complexity. Like there will be a lot of operations done. So I think we can. Yeah. Then do we have another examples maybe?
Oh, okay. Okay, the ones that are provided here, they're not exactly the best options. So let me try to write an example. So what are you having trouble with? Maybe you can ask me what kind of things are confusing you.
I mean, I'm just thinking of whether I should sort the whole, whether I should take the whole possibilities here or
All
not.
possibilities. What would be? Let's see. What would be the time and space complexity of that? What you're asking for is trying to sort every subarray, right?
Mm-hmm.
And then, what's the time complexity of sorting every subarray? Like, what's the time complexity of sorting one subarray?
Just sorting one array, it's going to be just the length of the array times log of the length of the array. It means if the length is n, then time complexity will be n log it. And we got sub arrays length starting from 1 up to the whole length, like the length of the whole array. So for example, here the whole array has
How many
the size
subarrays
of,
in total?
we got 7 elements in the array, right?
Yeah, there are 7.
Okay,
yeah.
so we got one array with 7 elements, 2 array with 6 elements, 5 with 3. I think in terms of n,
Just by approximation, in what order is the number of subarrays? Is it linear?
yeah, it will be,
Is that what you're saying?
yeah, n plus, like n minus 1 should be twice, n minus 2 should be, I think it will be n square, right?
Yes.
N square
So
number of subarrays.
Yeah. We're trying to do n log n square times.
Yes. For each of these subarrays, we do n log n complexity. So it will be n cube log n, I think.
Yeah, I think that's a little too much.
Yeah. So
Maybe better.
yeah. Okay, let me just think 3 minutes, then I'll get you back.
That's fine. That's fine.
Okay, what I'm what I'm trying to do is, when num is sorted, I mean, here it is it's saying after we sort some part of the array, then we don't have to sort the others, right? So it means some of the elements in the array, they are placed in, I mean, if we have the sorted version of these nums, for example, the sorted version of this will be 2, then 4, 6, 8, 9, 10, and 15, right? So we can see that some of the elements are already in their place. So here, for example, 2 is at the right place, but 6 is not at the right place, right? So what do you want? What we want to do is we will pick some part of the array which is not at the right place. That is one of one of the methods that I'm trying to follow here. But the other thing is, for example, let's say the minimum, we got some minimum element in the nums. If it is placed here, for example, and not here, it means we will have to sort the whole array, right? So what I'm thinking is to search for the minimum elements, then sort up and sort up to until that point. Then I check whether the nums is sorted, whether nums is sorted after this operation or not. If it is not, I'll search for the next minimum. Then I sort the array up to that point. Then I check whether the nums is sorted or not. So let me go over an example here, if it is not clear. So for example, I got, let's say 3, 4, 2, 1. Okay, then 0, 5. Let's say, and we can modify the example in order to make it more sensible. Okay, so here we can see that the minimum element is here, and I mean we are sure that we're going to have to the subarray here, otherwise 0 will not be at the right place. So I'll sort all the elements here, because the place of 0 is at the first index. So I have to sort all the elements starting from the 0th index, from the first index up to the current index of the minimum element here. So I do sort this, like it will be 0, 1, 0, 1, 2, 3, 4, right? Then I'm sure that this part of the array is sorted. I mean, it is sorted, but we can have some elements here that, for example, it could be, we could have 0 here, right? We could have 0 here, and we could have 4 here, for example. Then in this case, I have to sort all the elements up to this point. Then
is this assuming that the sortable part is a prefix all the time?
Yeah, I mean, we can start assuming from that, and if it is not valid way of thinking that, we can change it. Yeah, so I start from, maybe I can start from the last index. I can iterate up until I found the minimum element, and when I find the minimum element, I have to sort.
So basically what you're trying to do is finding the minimum element and sorting the prefix starting from there.
Yes, but we could have
yeah.
Okay, we can check the suffix if that works.
Same goes for the suffix, right? So in the case where 1, let me give it space, 1, 2, 5, 4, 7, 8. This is the part that's an issue. So for the minimum element, it's 1. How would you go with this?
Okay, so here the minimum element will be 1. So I just sort 1. The time complexity will not be that much. Then I'll start solving the rest of the elements here. Then here the minimum element is 2, and sorting just one element will not be costly. Then here, for the rest of these elements, the minimum is like 4. So I'll sort. Maybe I don't have to sort all the suffix, the prefix here. I could just start from the point that I start. Then I'll sort the subarray here. Then it will be 4, 5. Let's say 4, 5. Then moving to the next one, the minimum element will be just 5. And sorting just one is not going to be costly. I keep doing that. Then yeah, that will then the finally that will solve it.
Okay, I'm trying to see if there are situations where just looking for the minimum element would be useful.
Okay.
Okay, I guess basically this is a form of selection sort, right? So you start
we take we take the minimum
for each index. We try to find the smallest element, or basically something like that. I'm finding it closest to selection sort. In any case, what would be the time complexity?
Yeah, it would be n log n, right? Because at the if the element
What's
the minimum
of the sorting?
What is it?
What would be the sorting cost?
Yeah, the sorting cost will be just the time complexity is n log n, and n will be the subarray that I'm sorting here. Starting from my current index up to the index of the minimum elements. So in this case, for example, my minimum element will be -1. I'll sort the whole array here. Then starting from the next index, which is out of bound, I don't have any other elements. Okay,
sorry. I'm a little confused actually. So you're trying to, you're assuming starting from that point, if I sort everything, then everything up to the minimum element. So at least you have to find the minimum element, right? What would be the cost of finding the minimum element?
It will be linear time. I mean, if it is at the end, it will be, I will iterate through the whole array.
Yeah, and how many times do you have to do that?
Until the end of the array, which is it will be on, because if we have another minimum, okay, I got the minimum array, I got the minimum element here. For example, if it is around here, I release the subarray here. Then once I'm done with that, I know that at least all the elements in this range are sorted, right? But some of the elements here, they might be, part of they are supposed to be part of the first group. For example, there might be 0 here, there might be 1 here. But since the minimum element is before these elements, they are not in the first array. So okay. So if I have to,
you're saying something.
I just continue.
Okay. So maybe I'm thinking of what if we were back here, and yeah, initially this was something like this, right?
Yeah. Yes. It was 2. Yeah.
What's the question trying to find?
It's trying to find some of the elements which is not at the correct place of in the sorted version. So the sorted version is here, and some of them are not at the right place. So I'm trying to find some window of the original nums. Maybe I can sort them like this. Then I can use 2 pointers, maybe starting from the last in the first and the last index. You know, as long as all the elements are at the right place, I'll just keep moving. Once I found, elements which are not at their correct place, I'll stop. Then I have to sort that. For example, let's go through this example if it works. My right will be, my left pointer will be here. My right will be here. And let's do the sorted version here. So the sorted version will be just -1. I think 0, then 1, 1. Yeah, then the next should be 2. Okay. Then 4, 5, 7, and 8. I think this is the sorted version. Then when we see here, -1 and 1 are not at the right place, so just I'll leave it because I have to sort this part. Then when I see here, it's also not, it's not also sorted. So it means I have to sort all the range between these two pointers. So I'll just sort all the arrays, then the minimum, the shortest sub-array which I have to sort in order to make it, sorted will be the whole length is here in this case. But if, for example, if it is -1 like this, then then let's see, what was the element that I did? Okay, it was 1. Yeah. So let's see. If it is like this, for example, then -1 is at the right place. So I'll just move my left pointer here. As long as it is not the same, as long as it is at the right place, I'll just keep moving. When it is not at the right place, then I have to move. This is part of, this is signaling that this part should be sorted, right? Then starting at the right one, 1 is not the correct number in the sorted version. So it means this is also part of the sub-array which have to be sorted.
Makes sense. So basically what you're trying to do is that you have a left side and a right side, and you go, you tighten the gap as long as they're in the same position with the sorted one. And yes, and by the time it's no longer,
once it is not,
when do you stop?
When it is not, I mean, when the elements in the original given array is not the same as the sorted versions.
Which elements? Are we on the left or on the right?
Yeah, both the right and the left pointers. Or first maybe I can start from the left one. I keep going forward until it's the same element. Then for the left one, I do the same thing. I keep moving. For the right one, I keep moving to the left, as long as it is the same version as the sorted version.
Makes sense, yeah.
That makes sense, right? You can go over the elements, once.
Yeah, that makes sense to me. Okay, what would be the time and space complexity of this? Or actually, yeah, what would be that? And maybe you can jump into what kind of examples you tried from.
Yeah, I mean the time. Let's see. The time complexity will be just. I'll sort the whole array. So I have to. The time complexity will be n log n, which is n will be the length of the original array. Then after that, I will just using 2 pointers. So it will be n operation at max. So space, I'll use a space of the same as the original nums. It will be sorted, but it will take the same space as the original array. But other than that, I don't consume any space. So the time complexity will be n log n, and the space complexity will be O(n), where n is the element of the, number of elements in the nums array.
Okay.
I think
Yeah, that makes sense to me.
Yeah. We need to know whether, the question is just technically some of the elements are in at the right place, but some of them are not. So if they are not at the right place, I have to sort them. So technically, when it is efficient, I think it will be at this time complexity. But if you want, let's say, we can. I think.
Let's see. Do you think there's a more efficient way to do it?
Yeah, I mean,
like
if you want an efficient solution, let's say in space wise, maybe we can have another solution. But if we don't have a trade-off in both time complexity and space complexity, I don't think there would be an efficient solution. But it's not the right way of saying that. For people in discussion part and
no, that's not the point. They're not the focus right now. So I guess, yeah, maybe, I don't know. If you think there is a better solution to do, you can definitely go ahead for it. Or if you feel like you want to implement this one, go for that too.
I mean, let's implement this.
In terms of time, I can tell you. Oh, yeah, there's 10 minutes.
Okay, yeah, I think it would be enough. But yeah, it is. I think it's okay if the elements are also 1, 2. Yeah, it will work for any kind of links. We can go over it once I implement it. Let me implement it.
Okay, I'll switch you to the question.
Okay.
Can you see it?
Yeah, I'm supposed to implement it here.
Yes. If you need anything from the whiteboard, I can copy it for you.
Yeah, I don't need anything, I think. First, I'll sort the original. Okay, no, I need the original one, right? So I will use the let's say sorted version, and let's us initialize with the original one, and let's sort since it is sorted version, I have to sort it, right? So here it will be sorted version will be sorted. Then I have my right and my left pointers. Then, let's start from the left one. As long as this pointer is less than, let's use another int, which is absolute size. Usually since this particular element is unsigned integer, it causes some problems when it gets negative. So as long as it is less than the size of the array, and nums at left is the same as the sorted version in L, then what I want to do is just keep going to the right. And then I do the same thing for the right one. As long as it's greater than or equals to 0, and nums at right is the same as the sorted version. I'll just keep moving to the left. So both my left and my right pointer should be updated as long as it is same as the sorted version. Then I will have another variable. Let's call it answer. We can say it's length. Then the length will be, yeah, I think since the right is, yeah, here for example, if it is just 2 elements, then yeah, we can just use, we can +1. Why I add +1 is, let's say just considering just one example will be enough. For example, here, if we can use the previous example, 1, 2, 4, 5, 7, 8. The left pointer will go until this point, then the right pointer will go up to this point. Then the length should be, when we subtract the right from the left, it will be 1. So since the answer is just 2, I'll use 1. I'll add 1. Then yeah, I'll just return lane here. I think that will be that will work it. We can also use we don't have to use any space. We can just.
Okay. And what test cases would you try on this?
Okay, let's say elements with just one length. They are already sorted. The minimum length should be.
Maybe write them as a list so that we can try running them afterwards.
Okay. Let's say just one element. In here, my left will be at 0, and my right will be also at 0. Then 0 minus 0. Oh, I think in this case we don't have any.
Would you left?
What will be the answer here? Yeah. Let me. Oh, it says 0, right? Okay. Here it's
maybe list
0,
out all. Okay.
Yeah, just for example, let me just do it for example 1. It's the right. My left pointer will be just 1, and my 6, 6, 4. Then the answer will be 4 minus 5 minus 1 here, right?
Which example is this? I can't see what you do.
I mean, for the first example.
Oh,
my left.
Makes sense.
The left one will go up to 6, which is the index of 1. Then my right will go up to 9, which is 0, 1, 2, 3, 4. I think up to 5.
Would it though?
Then 5.
Would it though? Maybe let's see that example. Write it down here maybe, and
here.
Let's see how it would work. Any example, it doesn't matter.
Yeah, I think.
Yeah, write it down here. And then
yeah, here
So initially, where's the left and where's the right?
Initially, both of them. Oh, okay. So here, let's initialize this one first. Okay, that was a nice catch. Oh. The right will be starting from n minus 1. In my left will start from 0. Then let's start from the left one, which is here. It will go up to the sorted version, let's say, the second element will be 4. So it will stop here, which is a value of 1 index wise. Then the left one, which starts from the right one, it will go up to this point, which was supposed to be 10. So it has a value of 5. Then the answer should be a length of this one, right? So the answer it should be 5 minus 1 plus 1. But for example, in this case, it's already sorted, right? It's already sorted, and my left one, it will go up to this point, which is out of. Then this one is this one is 4. Then my left will stop here, which is a value of 3. Then 3 minus 4. Yeah, the right. I mean the right. Then the answer will be 4 minus 3 minus 4 plus 1. So it will always work. For the case of 1, it also works because the left one will go to up to 1. Then the right one.
Sorry. Why would it stop here? What's the condition that stops it?
Which one?
The right pointer. This is the right one, right?
Mm-hmm. Okay. Yeah, so what I will do is if the right minus 1, if the right minus lane, if it is negative, then I will just return 0 because the nums is already sorted. Then I don't have to sort any of the elements here because here you are right, the right will go up until this point, which is minus 1. Yeah, so technically what I will do at the last one is just if it is less than 1, if it is less than 0, I'll just return 0. Otherwise I'll just return L minus 1 plus 1. Okay, I think
and
this will
R minus and yeah. Okay, so I guess this works for the 2 situations, right?
Yeah, right.
And maybe other test
also
cases
for,
you want to try.
Yeah, also for just for 1.
You want to run it or?
Yeah, the left will go up to here, which is 1. Then my left one up to, it will go up until minus 1, and their difference is less than 1, so I should return 0.
Okay.
Yeah, I think this.
Any other test cases you want to try? Okay. I don't think anyone else should speak.
Yeah, I think the question it encompasses all the test cases.
Okay. You're good? You want to run them?
I think so.
You have a couple of minutes, so try running them and make sure that the code works so that I can try submitting it for you.
Okay, so I can run it, right?
Yes, you can, and you can try the example test cases you have put down.
And and maybe just minus 1. Seven 4. Oh. I think this will work. I should have. Yeah, I think this will work. The test
Okay,
case
should I try?
encompasses all the test case, I think.
Okay. Should I try evaluating it? Or is there anything you want to go through and review maybe?
I mean, the time is almost.
Yeah.
It's up.
Yeah,
So.
time's actually over, so I'll evaluate.
Yeah.
Yeah, it's accepted. Okay, you're good. And I guess you both finished in 45 minutes. Expected 40 minutes for both of you, but 45 it is. Okay, thank you, Nati. All right. That's what I have, I guess. Like, any questions from any other people first? Any opinions about how that went? Emre, are you going to say something?
Yes, no questions, but a few kudos for some reasons. First off, Ishaq, I think this was a great choice of a problem. Like, this is very interview-like a problem, you know? Like, from that perspective, it fits really well. And I think you ran the match like very, very good. So it was a joy to watch. And I want to thank you for that reason. And also, I want to celebrate Mati as well. Like, he went till the end, and he didn't give up, and he got there. So, thank you.
Awesome. Okay, so I've been trying to take notes for both interviews. Oh, actually, before that, I want to see if there are any other opinions from other people too. Okay, I'll assume none.
You ask something? Isaac?
No, I asked if there's any opinions about how that went. If you have opinions, you can share.
No,
I guess you didn't see Mahi's interview, so
yeah.
Okay, so from my perspective, I think they were interesting candidates for sure, both of them. One thing I found funny is at the beginning, I tried to limit the information they have so that they'd ask more questions, and they both asked interesting questions, but they were both different questions, both important but both different, and a combination of the two would have been like the perfect kind of questions to ask. Yeah.
What did she ask? I wonder.
So she didn't ask about constraints, but she asked what would happen in certain different examples, kind of, if that makes sense. So what happens in this case, and what happens in this case, and stuff like that. And what you asked is, what are the constraints? Can I have empty arrays? Can I have stuff like that? So that I found funny. So.
And do you think it's a very nice question for interviews? Like, what would be the result for this test case?
Yes, I think it is. But usually, if the interviewer feels like they want to see how much you understand the question, they can ask you to give the result by yourself. What do you think the result is? And then if you get it right, they'll confirm it for you. Okay. So it's a test of how well you understand the question. It's not necessarily trying to ask them the solution or anything.
Okay.
Okay, so I like that both, but in terms of constraints, like I actually wanted to see if you had an n-squared solution or anything. So I just gave you a little smaller constraint than it is. Like in the question, there is 10 to the power of 4. I gave you 10,000, so that because Mahi started off with an n-squared solution, and I wanted to see if you are going to do an n-squared solution as well. So yeah, that's that. And yeah, like I think understanding the problem was nice for both of you guys, and your first approaches were both brute force, and actually both approaches that I hadn't thought of for this solution. Both solutions I hadn't thought of for this question. But in the end, I think I had to give you both slight hints, I guess, on two places. So Nati, you may not know this, but I think Mahi found the linear time solution, which actually I guess it's requested by the lead code as a follow-up as well. So one thing I like is I like your confidence in what you do. So whenever you feel like you've done something, you have confidence in it and you go all in. I like that, and you don't spend too much time trying to doubt yourself and stuff like that. One thing that cost you is, I guess I wouldn't say costing, but I see it in a good way, but it made you think you don't really need to go further with that solution, and login was good enough for you and you implemented that. So what happened? Oh, should we call Mahi, by the way? Is she out?
I'm here.
Oh, okay. She's in. That's good. So what happened with her is she described the OFN solution, but since she didn't have much time, she just implemented the sort solution like you did. But I think it took you a little longer to implement than her. Granted, you're using C++. But yeah, I think it went well in that regard. I had to give Mahi, that I remember, 2 hints: one for nlogn solution and one for the OFN solution. But still, she caught up quick and solved it finally. And I kind of had to, like, the problem with Nati was that you kind of complicate things too much. So you immediately thought of the sorting approach, and then you went way out of bounds and got confused by yourself and confused me as well. So I tried to return you back to the original state. But yeah, like, I think if you hadn't gone through that whole complication thing, this would have been way in your court, because you found the sorting solution very early on. But because you went down a rabbit hole, I don't think this, like, I don't think you came back to it quick enough. So yeah, I just, because of that, and because Mahi also found a linear solution, I think I'm gonna have to give this one to Mahi.
Mhm. Okay,
You guys
nice.
still did good though. I can start crying now.
Isaac, thank you very much. Like any extra information you want to provide for especially community and new group students?
Who's that question for?
That question's for you. Like overall, with the whole play, if you try to put yourself in the shoes of the new group students, like to make it more approachable to them, what would you like to say to them?
Okay. I want to get them into the perspective of what you said early on. So I tried to pick a question, or I tried to also tell other interviewers to pick a question that has multiple ways of solving it, like multiple layers of a good solution. And I would, like, whenever, like, the interviewers would try to go for that, because it will give them more questions if you do well in one way of solving it. And whatever happens, like, whenever you feel like there's multiple ways of solving a question, at least mention one way that you understand. So one thing I liked about Nati is, once he found a solution that would properly work for, like, the nlogn solution, he didn't want to bother with a different one, because he didn't have that much time to worry about it. Mahi, you did that and risked having to not have time to implement anything, but in the end you did have, I guess, enough time to finish at least the nlogn solution, and so that worked out well. But if you don't feel like it's not going to go out, at least you have one solution that works. So keep that in mind, and I'd recommend, like, trying to see all the solutions that would work for you, basically. And yeah, and try to think more generically, I guess. So Nati was using some C++ methods, or talking about some C++ methods where you can partially sort an array. I have no idea. I've never heard of such a thing in Python. So, like, if you think that your solution is a little too specific or dependent on a framework that exists in your language or something, then it's probably not meant for the general public, and there's probably a better way to solve it. So no need to worry about partial sorting in this case, for instance. So, like, I think having to think about the partial sorting is what drove you to a rabbit hole when you already had a sorted array, basically. When you already had a sorted array, you went through the partial sorting way instead of thinking of a different method. So yeah, maybe cut it short when it's too dependent on a library as well. Yeah, that's what I have, I think.
Thank you very much, Ishaq and team. In front of everybody, I would like to congratulate everyone who has been an active part of this organization, because we do this with live broadcast. Like everybody sees, they have no idea about the problem before. There is a risk of maybe putting yourself in kind of an ashamed situation, like which people may think like that in the first place. And everyone had the balls to be on the stage today. So this is very good, guys. So from every session, we are learning. And from today's sessions, we also had some feedback. And starting semifinal, we want to do this in person. And we are going to do it on the whiteboard first. And there will be also coding session in which you will actually see all aspects of the problem solving during the interview. And for the final, we are going to make it full interview with the introductions, questions by the end. And even for the semifinal, we may consider this, or for the third place game. And guys, I believe this is a very good start. And we all know that good can always be better. And this is one thing that we want to internalize at A2SV. So please provide your feedback. Talk to me, talk to Ishaq, talk to other teammates. And if you can think of ways of making this better, please let us hear as organization team so that we can make this better. Because this is the first time we are organizing A2SV Champions League. And from every game right now, still, we are learning a lot. And of course, this is just the start. Let's stick with it. And all together, we will see where this is going to come. But again, everyone, please think of contributing. If you are part of the session right now, if you are one of these 26 people, including myself, then it means you care about A2SV. You care about the values A2SV provides. You care about the education A2SV provides and opportunities A2SV provides. And I'm so glad we are all in a Sunday evening together at 8 p.m. This means a lot, guys. And yes, for everybody here, please, you are part of this team, you are part of this ship. Contribute with your ideas and let us know how we can make it better. And let's see where this your journey is going to take us. So again, Nati, Mahlet, thank you very much. This was a very enjoyable performance. Like this game, I was able to observe it from outside, right? The referee is there. I'm not part of it. The previous game, I was the referee, so I'm into it. I cannot make similar observations. But for this game, I was an outsider observer. And it was a joy to watch. Thanks for making this happen, guys.
That's awesome. And one more thing, sorry. There are some questions that are asked in the text, and I just wanted to point those out, I guess, for those who didn't understand. So one said, both did great. The first one presented 3 solutions in the same time, and the second one was better communicator, which is a good point. And what I wanted to talk about is how do we know if she got a linear solution if she hadn't implemented it? And for that, I want to say that like implementing solution and coming up with a solution are like separate skills basically, and like having to implement it is to test if you can code, not necessarily to know that you have a solution. So that's all. Thank you, and have a good day, guys. I guess a good night.
Thank you. See you guys.